So in this video, we are going to continue solving a problem from exercise 8.1, which is from chapter number 8, quadrilaterals. So in this video, we are going to see problem number 9. Let's read what the problem is. In parallelogram ABCD, so A, let's use a highlighter, ABCD, this is my parallelogram. 2 points P and Q are taken on diagonal BD. So 2 points P and Q are taken on the diagonal BD, okay, such that dp is equal to dq. So let's highlight this. It's an important piece of information. dp is equal to dq. Okay, so where is dp? So let's use the same color to highlight dp. So this is dp, okay, and this is our bq. dp is equal to bq. Now we have to show that this is a piece of information given to us. Show that number 1, number 2, number 3, number 4, number 5. There are a lot of things to be shown. Let's focus on the first thing that we have to show. The first thing we have to show is triangle APD. So APD is congruent to triangle CQB. So CQB. Okay. So let's try to prove the first part of it. So what I'm going to do is I'm going to construct the same diagonal but with the lesser uh, pieces of information. So in this given figure, there is a lot of lines and a lot of diagrams which are drawn. So it might be a little bit overwhelming to think about it. So what we are going to do is let's construct a similar figure. Okay. Oops. Let's take our straight lines. So this is our diagonal. Okay. Okay. Let me. Yes. So a bit better. So let's try to erase this. Now, let's give the same names. First of all, this is A, B, and C and D. Okay. Then they have taken the diagonal BD. So I want to take the diagonal BD here. Okay, I forgot to take the straight line. So let's construct a diagonal BD here. Yes. Now on diagonal BD, as the problem suggested, on diagonal BD, okay, on diagonal BD, we have 2 points P and Q such that DP is equal to BQ. So let's take 2 points P and Q. Yes. So let's say this is my point P. Okay, let's say this is my point P and this is my point Q. So we have taken 2 points such that BQ is equal to DP. So let's write it down. DP is equal to BQ. Okay, and now we have to show the triangle. Okay, triangle APD and CQB are congruent to each other. So what I'm going to do is I'm going to just connect this. So let's connect. Okay, I'll use the same color. So this is one triangle and this is one triangle. Okay, let's remove this Q. Okay, I'll just write here Q, and now this becomes my triangle BQC. Okay, we have to prove. Oh, so we have to prove triangle APD is congruent to triangle. I'm worried about the APD and CQB. Okay, APD and CQB. The order is important because, as we know, in proof for congruence of triangles, the order in which you write these triangle names APD and CQB are very important. So this is the first thing that we have to prove in our problem number 8. So let's begin. So we have given piece of information that ABCD, okay, is a parallelogram. So in parallelogram, the opposite sides are equal to each other. So that is the first piece of information, that AD, okay, is equal to BC. So I'm just going to start noting down these points. Okay. So point number 1, AD is equal to BC, or rather I'm going to say AD is equal to CB. Okay, AD is equal to CB. Why? Because this AD is equal to CB. That order is very important. In proving the congruence of triangles, we have to follow one-to-one correspondence. So AD is equal to CB. What is the reason for this? Opposite sides, okay, opposite sides of a parallelogram. So this is the first piece of information. Now second piece of information is this thing. DP is equal to BQ, okay, or rather I am going to again follow. So let me remove this. Yes. So let's erase this highlighter. Now I have to write DP is equal to BQ, okay. So I am going to say this thing. PD is equal to QB, okay. I'll highlight here. PD is equal to QB. Why? Again, that is given. So let that be the point number 2. That side, okay, PD is equal to QB. Why? This is given. Okay. Now we have to prove that these two triangles are congruent. We have got two sides which are congruent to each other. So the third thing which might help us to prove that these two triangles are congruent is a side, which is an angle which is included between these two sides, and that angle is nothing but this angle and this angle. So let me use highlight. Should I use a highlighter? Okay, let me first erase this highlighter. Yeah. So all I have to prove is this angle is equal to this angle. Okay. Is that possible? Yes. Why? Because in parallelogram, AD is parallel to BC. Opposite sides are parallel to each other. And this diagonal BD is an intercept. So this angle ADB is equal to DBC because they are alternate interior angles of two parallel lines. Okay, so this angle is equal to this angle by that property. Now we have to be careful about the way we write it. It's going to be angle ADP. Okay, in fact, let me use 1, 2, 3. So 1, 2, 3 ADP, and same order is important here. 1, 2, 3 CBQ. Okay, C, B, and Q. So let's write that down. So the third point is going to be angle ADP is equal to angle CBQ. Okay, why? Because they are alternate interior angles. Alternate interior angles. Okay, thus we have, now focus on this point. We have this side BC equal to AD. Okay, then we have this angle equal to each other, and then we have BQ as equal to DP. So side angle side. In side angle side, the most important point is the angle has to be included between the two sides, which is the case in this two triangles. So I'm going to say thus, therefore, okay, therefore by SAS congruency test, we can say, okay, what can we say? Thing that they have asked to prove us, and that is triangle APD is congruent to triangle CQB. So we can say triangle APD is congruent to triangle CQB. Okay, and I'm going to box this because this is the first and very important point which we have to prove in this exercise. So let's go back to our exercise problem. Yes, so the first part is done, which says that prove that triangle APD is congruent to triangle CQB. Now let's focus on the second part. The second part says prove that AP is equal to CQ. Now this is very obvious. Since these two triangles are congruent to each other, it follows that all the three sides are congruent to each other and all the three angles are congruent to each other. So once again, if you focus on the sides, this is the side AP and this is the side CQ. So AP is equal to CQ is very obvious because just now we proved that these two triangles are congruent to each other. So point number 2 is also done. I want to just mark it done. So the next thing we have to prove is AQB is congruent to CPD. So once again, let us erase this. Okay, and focus on triangle AQB. So AQB, this is one triangle, and CPD. So CPD. Okay, we have to prove that these two triangles are congruent to each other. Now, how are we going to do it? We are going to do it exactly the same way that we did here. Okay, we are going to use the SAS congruency test. So, what I'm going to do is once again erase this. Okay, we have this side as equal to this side. Why? Because these are opposite sides of parallelogram. Opposite sides of parallelogram are equal to each other. Okay, then we have dp as equal to bq. This is a given piece of information, and then the angle included between these two sides, which is our, okay, this angle and this angle. These two angles are included between these two sides. These two angles are equal to each other. Why? Because these are the two parallel lines and BD is the intercept between the two. So thus, by the same logic and the same way we prove this whole thing, by SAS test, we can prove that these two triangles are congruent to each other. So I'm not going to prove it again step by step because the process is exactly the same. So again, by SAS test, we prove that these two triangles are congruent to each other. So once again, I'm just going to mark a tick mark. Yes, this is also done. Let me use a highlighter eraser to remove this, and let me also erase this part so that there is less mess. Okay, so these three things are done. Now the fourth thing that they're asking us to prove is AQ is equal to CP. Once again, it follows from this AQ CP. Once we prove that two triangles are congruent to each other, then AQ is obviously equal to CP because those are the two sides of the congruent triangles. So point number 4 is also done. Now the fifth and important point is we have to prove that APCQ is a parallelogram. So this part. Okay, so once again, let's use eraser to remove this. So we have to show that this APCQ, this is a parallelogram. Now, it's very easy to show this because we are going to use the information from, let me erase this. We are going to use the information from the first point. Oops. Okay, let's use a highlighter. Oh, okay. So let's erase this. Let's now we are going to use this. Sorry, yeah, we are going to use this information and this information. AP is equal to CQ. So I'm going to just mark that AP is equal to CQ, and then AQ is equal to CP. So AQ is equal to CP. So if you focus on this quadrilateral, okay, let's use a highlighter, APCQ. If you focus on this quadrilateral, then you can see that the opposite sides are equal to each other. Okay, why? Because in point number 2 and point number 4 we prove it. So we know that there are 4 conditions for a quadrilateral to be a parallelogram, and one of the conditions is, out of those 4 conditions, if the opposite sides are equal to each other, okay, then the quadrilateral will be a parallelogram. So this condition is satisfied in this problem. We have proven that opposite sides of this are equal to each other, and thus quadrilateral APCQ will be a parallelogram. So in that way, we can easily tick mark the fifth point, which is also proven. So thus we have seen that in this problem, we have to go very carefully step by step to solve and understand each problem. In case the given diagram is confusing and if it's a very overwhelming thing for you, then always go and draw a smaller version of the diagram where only the required pieces of information are needed to prove a particular point, and go ahead and proceed with your proof. So we have to be very patient and careful while solving these problems. They are not really complicated, but they are a little bit lengthy. So we have to go step by step and understand each point, focus on each problem which is asked at a given point and try to solve it. So that's it. This is how we solve question number 9.